Awesome. Thank you guys very much, and thank you for joining me today. Today I want to talk about something new called Chrome apps. And Chrome apps provide a really cool new set of functionality that I think is really useful for web developers to be able to build native-like applications. My name's Pete LePage. I'm a developer advocate on the Chrome team, and I work out of our New York office. I'm going to make these slides available offline after if you want to copy the URL down later, so you don't have to worry about copying any of this stuff down. But if you want to find me, you can find me on Google Plus or on Twitter and on GitHub as well. And all the demos that I have today are also going to be up on GitHub either later today or sometime tomorrow. You'll see some fun stuff with those lights up there. You've probably been wondering why they're hanging around up there. Well, we're going to make them do some fun stuff with our phone and with an app. So web apps, I think, are really amazing. There's a ton of phenomenal things that you can do with them. Helps if I start my timer too. Wunderlist, really beautiful to-do task manager. Helps you know what you need to get done. You can set all sorts of reminders and deadlines for things. Great, beautiful app, really useful. Financial Times built a web app because they didn't want to put their web app into the different stores because they didn't want to have to pay money to other companies. They wanted all of the revenue to come to them. Fair deal, I think, you know. Google Play Music can go through and please don't judge me on my music, but you can go and you can play all your music online, on the cloud. You don't have to worry about carrying it with you everywhere you go. Feedly. After Reader went away, I switched over to here, and this is a great app. It's fantastic. I can read all my articles. I can do all sorts of great stuff with it. But it kind of sucks once in a while, right? You get this. Crap. You go to use one of your favorite web apps and you're offline. Or maybe it's not that you're just offline. Maybe you're somewhere where there's no 4G connection. In the States, we say there's no 3G connection because, well, our connection's not so good. But where you don't have a very good connection, maybe you're going on a train where you're going to lose connection intermittently. Or what about if you want to access hardware devices? So think about playing games on the web. You can't exactly go and use your joystick. You can't go and use game controllers or other things like that. Or maybe it's a matter of you're stuck on a legacy browser and these new web apps require newer versions of browsers. They need something that supports modern HTML5 and CSS3 features. But then there's another piece, and it's the native integration component. When you go to run an application on your laptop, on your Mac, on your Windows computer, you go and you hit the start button or you hit the application on the dock. You don't open a browser window and then start typing in the URL. Think about all the people who are not as technically advanced who are in here, you know, maybe your parents, brothers, sisters. They click on the start menu. That's how you start an application. You don't go to a URL and expect it to work offline. If you're typing a URL into an address bar, it's not going to work offline. You can't Alt-Tab between applications if you want to go between different applications. You don't have that same level of integration that you expect to have. And that's where Chrome apps come in. Chrome apps allow you to build installed native applications that work just like every other installed app on your computer, but using HTML, CSS, and JavaScript. Just the way that we're used to building modern web applications, we can do that with Chrome apps. So let's take a look at a couple. I'm going to just come out of my slides here. And I loaded a couple already today. 500 pixels I think is one of my favorite because it's just really pretty. How many people are familiar with the 500 pixels website or web service? A few people. They have really, really pretty photos when it loads. We are still connected to the internet. All right, let's try this. It loaded before, I promise you. Chrome apps should work offline. That one clearly fails. But let me pull up Wunderlist. We talked about Wunderlist a couple minutes ago. Here's Wunderlist working as a Chrome app. Notice there's no address bar, there's no back or forward button, all the stuff that I need to do. All right, so for my trip to Korea, yep, prepare presentation, I did that. And pack heart rate monitor. I'll explain that one in a sec, but I've got a heart rate monitor on right now, so we'll take a look at that in a second. So then you can also do just really simple things. 1 + 1. Yes, success. All right? So you can build anything from apps that need a network connection to stuff that doesn't, to things that are just daily use, everyday utility applications, to complex applications like Wunderlist. You could write, if you wanted to, Photoshop in JavaScript, HTML, CSS, and get a pretty awesome app. All right, so let's pop back into here. So Chrome apps follow 4 important pillars. 1, we already saw that one shot down on some apps, but they should work offline by default. 2, they're cloud ready, so they can take advantage of all sorts of the great APIs and services that are available from Google or from anybody else. 3rd, they should be natively integrated. I tried to find a nicer sounding word for that, but it really didn't. That just does not roll off the tongue. But they should work with the system and use all of the APIs. And finally, multi-device capable. That means that Chrome apps are going to work no matter what device you're using, whether you're using a Mac, a PC, a Linux machine, and we're going to talk about the mobile experience today. But no matter what you do, you write your code effectively once, and it works everywhere. I know it's been said a million times, nobody believes it, but for the most part, this is true with Chrome apps. So let's jump in and take a look at what offline by default means. Like any app you install from any of the stores or app marketplaces, there's the Chrome Web Store. So a user goes to the Chrome Web Store, chooses the app that they want to install, which then downloads all of the assets and resources needed for that app to run. Now, what does that consist of? Well, there's 2 pieces here that are required. One, we need to have what's called the manifest JSON file. We'll take a look at that in a sec. But the manifest tells Chrome what that app, how to start it, how big the window should be, information, or not the window, but version number, all sorts of little stuff about the information for this app. And then there's the main.js file, which tells Chrome how to start this application. And then finally, you've got all of the application content. So that's all of the resources needed for your app to run. So that's all the JavaScript, the HTML, the CSS. Now, one key thing to keep in mind when you're building Chrome packaged apps or thinking about them is it requires a bit of a subtle shift in thinking as a web developer. As a web developer, we typically think, oh great, I'm going to go write some HTML, some JavaScript, and that kind of thing, and I'm probably going to have a Ruby backend, or maybe a PHP backend, or maybe an ASP.NET backend, and it's going to spit out HTML as well. So you're going to have some server-side code running as well. With a Chrome packaged app, you can't really do that. You can use client-side code to run all of your UI and all of that, and then you go up and use your APIs, services, to get data and then display that on screen. So in the manifest, how many people have tried writing a Chrome extension or a old-style Chrome packaged app? All right, a few people. So it's pretty much the same. There's only a few key differences that I've highlighted here, including the manifest version, which needs to say version 2. And then we tell the app how we want it to start by saying background and giving it an array of JavaScript files. So if we take a look at the JavaScript file that's in running behind here, so this is the main.js that's required to run, we set up a listener and we say, hey Chrome, anytime the user tries to start our application, we want to listen for those events, and when that event gets fired, we want to create a new window and open the index.html file. Obviously, you can open any file you want. You can open index or in the case we'll look at in a couple minutes, Hue, whatever you want. You can provide an app ID, which is really useful so that Chrome remembers where to open the window, and it stores state about the window. And you can also say how big you want the window to open. You can even go so far as to say where you want the window to open and additional properties you can set in there. But those are the key ones that you sort of need to be aware of. So beyond the ability to be able to work offline, in fact, there's one other thing that I want to mention here, is that you get the Chrome Web Store functionality with this, which means that like Chrome, your application will always stay up to date. So when you guys start using an application today, usually you pull out your phone, you sign into the app, and it asks you for your username and password, which you've probably created on a website somewhere, or maybe you've signed up on that app at one point. And you sign in, and everything's there, right? If you go sign into a Google account, use Google Drive, or you use any of your applications where you sign in, it remembers you, remembers all your settings. And everybody expects that today. And they expect their applications to stay up to date. So with Chrome apps, we provide the functionality to make that really easy for you so that you can just go and be good to go, your apps stay up to date, and your users always have the data. So there's a bunch of APIs that are available that make this much easier. One of them is the Synced Object Storage API. And how many people are familiar with the Local Storage API? Yeah, okay, so a few people. So the Local Storage API lets you store strings on the user's computer. Great. But if they go to another computer, or if you want to store a JavaScript object, not gonna happen. So with the Synced Object Storage API, you can store data for that specific user that will be synced to every computer that they sign in on. So whether I come and use my MacBook, whether I use a Chromebook, or whether I use any other device, all of that data is available on any of the devices. It uses the same syncing system that Chrome uses to store bookmarks and passwords, and all of the other information that Chrome stores and syncs across users. So that gives us a really great way to store application settings, or maybe state about the user or what they were doing. There's also a synced file system that's available. right? So that means you can go and store large files on the user's computer, but know that no matter what computer they go to, they're always going to have access to those files. That means I've got access to my photos across all of my computers, or maybe all of my documents, or my presentations. So I've got all sorts of file and data storage. But one of the things that I've always loved about Android is the ability to be able to send push messages to me to tell me about something new. And the web has never had that. Or it has. It's called spam. Right? I want web apps to be able to tell me when something is going on or when there's new information. Or maybe to wake up and go do something. So with the Chrome Push Messaging API, you can actually send data to a Chrome app and tell it to either pop up a notification like you would see on Android, or you can tell it to go and say, hey, the user just added a bunch of new files. You should sync these down. Or maybe the user has a new friend. Woohoo! So with their new friend, you may want to go get information about their friend so that you've got that next time they connect. So the Push Messaging API is a pretty great one and is something that I'm really excited about. There's also an Identity Services API. I hate signing in, right? How many passwords do people have? And please don't put your hand up for this. Don't tell me. If you use the same password for every site, yeah, probably not a good thing, but it's really easy to do, right? With the Identity Services API, if you forget your password or if for whatever reason your password gets compromised, you have to reset it in one place with the Google APIs, or if you're using one of the other identity services, you can have the user authenticate to that, and it'll give back that authentication token. Then they don't have let me rephrase that, sorry. Then you do not need to be in the job of storing users' names and passwords, because that just always gets messy. We hear about it on a regular basis of somebody who's gone through and lost every user's username and password, or maybe their credit card number. Generally not a good thing. You also get updates from the Chrome Web Store. So just like you do if you were to use an Android app or an iOS app, when somebody pushes up a new version, you get it automatically. Everything is all good. Now, on the web, you may be paying for bandwidth, right? So if you've got a website, you're paying for all of those megabytes or gigabytes, hopefully if you've got a good website going out. You don't have to do that with Chrome packaged apps. You push stuff up, and then we handle the distribution. So we're responsible for getting it to all 10,000 of your users or 10 million of your users, and we eat the bandwidth costs. Go click on a few ads. And then finally, there's a whole set of monetization options. So if you want to start selling apps, you can do either one-time payments or use the in-app payment model. Now, the thing that I love about this is instead of being, 30% like most other places, it's only 5%. All right? And this works anywhere where Google Wallet works. So I just put a little code up there so you guys can sort of see what's going on. But chrome.storage.sync.set, one thing you'll notice about that, I didn't stringify that. So you can store straight up objects in the Chrome storage. Syncs across all the user's devices. Really nice, easy way to be able to handle data across devices. All right, we've covered 2. We've got 2 more to go, and we've got some more fun demos. In fact, let's do a demo now. I like doing fun demos. All right. So it's always fun to do a demo when you have to get off the network and switch to another one. So I'm going to cross my fingers here and switch over to this other network. And let's bring up this guy. All right. I'm alive. Sweet. Okay. So right now, I'm wearing a Bluetooth heart rate monitor. You probably can't see it through here, and I'm not going to pull my shirt up so that you can see my chest. That will not be pretty. But there's a heart rate monitor under here that's connected to my computer via Bluetooth. So right now, it's probably not a good heart rate for this, but okay. We know I'm alive. Now, that light just came on. Did anybody notice that? And it should be flickering at about 105. I'm dead. Crap. That's not good. I need to be very close to my computer, apparently, if I want to stay alive. I feel like I should be on an episode of 24 if you move far enough away from the computer. All right. So I can't see if that light is flashing, but that light should be flashing right now. All right. Sweet. So what's going on is through Bluetooth, I'm connected to this guy, and I'm going through and saying, okay, great, getting the heart rate. And then I'm using, and I'll open this up so we can see what's going on here. Oh. I'm using the Philips Hue light bulbs, which are a really neat set of LED light bulbs that allow you to control them by making an HTTP request. So I'm making an HTTP request to this light every time I'm for 80 beats per minute. So you can see as it's going through, it sets the hue at 0, which is, if you think about the circle, it sets it at red. The saturation, nice and bright, and then it goes between 200 and then down to 128. So it's doing a rate with my heart rate. All right. So I mentioned that you can alt-tab between these guys. Because I'm running Chromium right now, this is not something that's available. And Bluetooth is still an experimental feature. Chrome apps launched in mid-September for all users. But we still have a few APIs that we haven't quite shipped yet because we want to make sure we get them right. And Bluetooth is one of them. So it's only available in either Chrome Dev, Canary, or in Chromium as I'm running this guy here. So let me come off of this and we'll pop back to this guy. All right. Do we get back on the network? This is always the fun one. Woo! All right. Sweet. So you'll notice in that app, there was no address bar or anything like that. And in fact, that app looked different than the Wunderlist app. The Wunderlist app, in fact, let's just bring it up so that we can see it. It should run. There we go. The Wunderlist app looks exactly like we would expect it to look on a Mac. It's got the little red X, the minus sign, and the plus sign. But the heart rate app, it didn't, right? Like, it's only got this X over here. With Chrome apps, you can make the app look however you want. If you want to have it have that native look, you can do that. If you want to give it something completely different, oh, that wasn't a good heartbeat. All right, we're going to get out of here. So if you want to make the app look however you want, you can do that. One thing I would caution you on is don't go too far to try and create a native looking app because operating systems change. Or if you don't put the right amount of effort into it and a user goes and uses something that looks like a Mac on a PC, they're going to be really confused, right? So just be really careful about how you do that. So these apps get launched from the taskbar. So if I go down, I can launch apps exactly the same way. And there's a whole set of additional APIs that give me more native integration. For example, the Alarms API allows me to go through and set alarms so that applications run on scheduled tasks, just like setting up a cron job or a scheduled task in Windows. Or I can use the Media Galleries API to be able to go and access all of the content that is in my medias folder, or my media folder. So like my pictures, my videos, and my music, so that I have all of that access for those applications no matter where I am. But it also means that, like we saw a moment ago with the heart rate, I have access to Bluetooth, USB, and even raw networking APIs. So in order to communicate with the Hue, I was making just simple AJAX requests. I was just using jQuery and saying, hey, go just make this AJAX request. But the Hue, I won't pick it up. The Hue has this little hub. And in order to find the IP address of the hub, you can either open up your browser, go to your networking switch, go look up the IP address, and then plug that in, which is not very nice. It's kind of ugly and a small pain in the butt. Or you can do an SSDP query, which is, I don't remember what it stands for. But effectively what you do is you send out a UDP packet to a broadcast IP address, and you say, hey, are there any Philips Hue hubs out there? And then you sit back and you listen. And after a few seconds, the hub comes back and says, hey, yep, I'm here. I'm on IP address, whatever. Imagine trying to do that with an HTTP request. You can't send an HTTP request to a broadcast IP. It just doesn't work. So you can send raw TCP or UDP messages out to any IP. Think about that for a sec. You can do anything you want with raw network support, which means with Chrome, you could write your own web browser, which would be a little silly, but you could do it. Or you could write a web server. So you could have Chrome acting as a true HTTP server. You could write your own WebSocket server. So there's a lot of stuff that you can do with this now that you have full network access. USB means that you can go and access any USB devices. I was going to try and do this demo earlier today, and I can't get my Chromebook to work on here. But I've got a Griffin power knob here. This is something that you guys may have seen. It came out maybe 2 or 3 years ago. Really cool, but totally useless electronic toy. Little spinner dial, so it spins. Woohoo, yay. You can push it and click it once. Woohoo. Or you can push and click, or push and turn. Yay. That's about all it does. They sold it for $75 when it first came out. It's about $30 now. If you're looking for a fun toy to play with, it is kind of cool. So we'll take a look at how I use this in a sec, but that means you can use devices like this or any other USB device without the need for any custom controlled drivers or anything like that. How many of you guys have seen those USB missile launchers? You can get them on like the little electronics stores in the States. We sell them on Amazon. And it's It's a Nerf gun, effectively, but it's got a little missile launcher. You plug it into USB. You can control this sucker with a Chrome packaged app. So there's lots of different things that you can do once you have access to raw network, to Bluetooth, or to USB. So this is actually some of the one of the commands that I use to control the spinner dial here. But all we do is say set the brightness. You create the object that you want to have. So in this particular case, I said, hey, I want. Whoop, I just gave away the next half of my presentation. What you want to do, so I want to send a packet out to endpoint 2, and I just want to send out this data, and that will set the brightness on the LED for this spinner guy. So quick and easy way to be able to set that. The hardest thing about using this is actually to reverse engineer the protocol to figure out what you need to send. So I talked a little bit about Chrome packaged apps should just work on any device that you use. Whether you're using a Windows device, whether you're using a Chrome OS device, whether Mac or Linux. Chrome apps work wherever you expect them to work. Actually, before I go in there, let's go check out one other demo. I got to switch back on my network here. I'll pop over here. All right. So I don't have the USB dial hooked up on this one. There's a little bit of stuff that we're still working on. When you plug this into a Mac, it sees this as an HID input device, and our API for that is still coming. But on a Chromebook, it works just fine. So now that we're on here, I've created this Chrome app that effectively does the same thing as my heart rate monitor, except it's a little bit more fun. So let's go here. And all right, so we got a nice green light. And don't you just love that shade of green? Well, I like blue better. There we go, we got some blue. And ooh, that's kind of pretty. So just by moving these dials up and down, we can go through and try this. During the break, after whoever is up next, I think it's Jake. After the break, I'll set this thing up with the dial so that if you guys want to come and just spin the dial, it's almost as much fun as spinning a wheel, but you don't win anything. You can try it, you can play with it and see how it works. But effectively, we're just doing the same thing here where every time we move this, we're going through and sending a new HTTP request. Now, I would be smacked upside the head if I didn't say that perf matters, all right? So one of the things that I did while building this app, and you guys should think about as you're going through, if I were to fire an event for every single move here, this thing would get really unresponsive. It would start bogging down. My light wouldn't change as quickly as it does, right? So as I move this over, it still doesn't quite change as fast as I want. So the way that I wrote this is that I'm using a request animation frame to go through and fire and check to see what the value of this slider is. So this guy's running just 60 frames per second going, okay, has that slider changed? Nope. Has that slider changed? Nope. Okay. Oh, it changed. Okay, now I'm going to set this new value. So that way, I'm not firing 255 events as I move that way over there really fast. I really probably only fired one event as I ran across there quickly. All right. I gotta get back. So these apps should work everywhere that Chrome works. So whether that's Mac, PC, Linux, Chrome OS, they should just work. But one of the things that's been really important to us from day one is to make these apps work across all devices, not just desktops and laptops, but mobile devices as well. And so this is a project that's still under development. You can go try it if you want to go grab the code at GitHub. The instructions are accurate. I did it last night about 3 o'clock in the morning. It works. I wanted to make sure I was up to date. Yeah, that's it. I couldn't sleep. But that's going to mean that your app is going to work on Android or iOS using Phonegap or Cordova. How many people are familiar with Cordova or Phonegap? A few people. Effectively, what Cordova does is do exactly what Chrome does, where it takes all of the assets and resources that are required for your app to run, and it uses a web view to render those, and your application just works. So you're good to go. You can be running the app in the same way. Now, obviously, you're going to need to make a few changes to your application, because if you designed your application like, say, Wunderlist, where it's a nice big screen, that might not fit so well on here. We've all seen desktop websites on a mobile device, and it looks not pretty. So you want to take that into account. So I said I had spent a little bit of time last night. So let's bring this guy up. Well, you all know my password now, so there goes that level of security. All right. So does this look familiar? Well, it looks also nicely out of focus, but here, so I'm going to change this brightness. Let's bring the brightness up. And the light is kind of greeny. Let's see if we can make it blue. All right. So this same app doing exactly the same thing is now running as a mobile Chrome app. And you know my phone password, so you can come play with this afterwards too. So you've just got that same ability to be able to take a Chrome packaged app and make it run anywhere. And in fact, the process is intended to be so easy. What we want you to be able to do is say, build a Chrome, type in on a command line, build a Chrome app. Not quite literally that, but close enough. Enter. It'll then go and create the Eclipse project for you. It'll create the Xcode project for you. And then all you need to do is go to the development environment and hit run. And it just works. All right. So Chrome apps are a new way to build desktop native style applications using the tools and the skills that we know and love today, using web technologies. If anybody's tried using any of the Chrome embedded framework stuff, I was talking with somebody earlier who was thinking about using that. That hurts. That's just painful, right? This, super easy. There's no DLLs to update. There's no C or C++ code to compile. You're good to go. You can just write the HTML, CSS, and JavaScript that you know and love today, and it works offline. It works with all of the cloud providers and gives you a great way to be able to store data up in the cloud. It gives you full native integration so that you can alt-tab between apps. Users start apps in the same way that they're used to, and it works across all devices. Now there's one other thing that I'm going to mention. We haven't talked a lot about it, but this is something that I think is really interesting, and when it comes to fruition is going to make these apps a lot more interesting. Today, if you go to the Chrome Web Store using Internet Explorer, we sort of smile politely, pat you on the head, and say, please install Chrome and come back, right? We want to get this to a point where if you come to the Chrome Web Store using Internet Explorer or Firefox or Safari or Opera, you can click install on any of those apps, and we'll handle all of the magic for you and install the Chrome runtime on the user's computer. Won't necessarily install the browser, but the runtime will be there so that you get the same experience as a developer where you've got the latest Chrome, the user's got the latest version of the app, and you're all set, you're good to go, and you don't have to think about it, and the user has no clue that they've just installed Chrome and they're using your app as a Chrome packaged app. They just know that they've installed this great app that you guys have written. So the link for the slides is up there. I think I've probably got like 5 minutes left, maybe 3 minutes left. About 3 minutes left. The link to the slides is up there. There's also some learn more stuff there on that last slide. Are there any questions? Yeah, so the question was, in the manifest file, we have a JavaScript file that is our background script. Does that work on the mobile device? And the answer is yes. We have a special set of wrappers that you'll find at that link that will go through and look at the manifest file, look at the main.js file, and figure out how to package all of that into the Cordova environment so that you don't have to do anything. The cool thing is you have one code base and you don't have to go and screw with it to get it to work in other places. We'll handle all of that for you. All right, I'll be around after the break. Thank you guys very much. We'll play with the lights later. Thank you.